Hey guys, I hope you had a good weekend. We're into the second week of June. So we will be continuing with linear relations and writing equations. So last week we did partial differentiation and partial variation and direct variation. And then we did writing equations from word problems. So this week we're going to cover writing equations from graphs and writing equations from charts. And those are the three things that you need to be able to write equations from: word problems, graphs, and charts like tables. Okay, so today we'll cover the graphs. But I want to start with a quick review from last week, going over the word problems, and I'm going to do two of the questions that you had from your worksheet. Okay, so you can kind of check, follow along, make sure you did it in the right way. So just a quick reminder that this equation right here, okay, is one that you would always be given, okay? But you're just given the equation, so you do need to know what everything stands for, and of course you need to know how to use it, okay? So just a reminder, here we have the dependent variable equals the rate of change times the independent variable plus the starting point, okay? So I'll just write this out. So SP is the starting point, okay? And sometimes that's 0, right? If it's direct variation. So if it's direct variation, your starting point will, just right here, equal 0. If it's partial variation, then it will be something else, okay? Something else that you're starting at. So anything but 0. Okay, so that's the starting point. ROC, of course, is the rate of change. Okay, so what things are going up or down by, and because it's a linear relation, the rate of change will be constant. Okay, so it's constantly going up by something or constantly going down by something. IV is the independent variable. Okay, and DV is the dependent variable. Okay, and important to be able to differentiate between the two. Okay, so sometimes saying out loud whatever the variable is for this one, it will depend on the independent variable, or it's affected by the independent variable. Okay? Okay, so I will do two questions from the worksheet from last week. So first question, I believe these are the first two just from your worksheet. So it says a family meal deal at Chicken Deluxe. Okay, so I won't write down everything, but this is the Chicken Deluxe question. Okay, and the information that's given, that the family meal deal, so family meal deal costs $26. Okay, and then plus $1.50 for every extra piece of chicken. Okay, plus $1.50 for an extra piece of chicken. Okay, so for each extra piece of chicken, it's $1.50, and you have to come up with an equation. So we'll do what we did before, where I'm going to write down my equation. I'm going to write down these four things. Then I'm going to start filling in what each one equals. Then I will write my equation. Okay? So, quick reminder that dependent variable equals rate of change times the independent variable plus the starting point. Okay, just kind of keep that there. So, our starting point. Okay, if this was direct variation, then the family meal deal would basically be nothing. It would just cost per chicken, okay, per piece of chicken. But this, there is a base fee, so that right there is your starting point. So your starting point is $26. Your rate of change, what is this going up or down by at a consistent rate? Well, it's $1.50. You add one piece of chicken, you've added $1.50 to your $26. Add another piece of chicken, you've added another $1.50, and it just goes up from there. Okay, so we'll say 50. And then we have the independent variable and the dependent variable. So you have to ask yourself, okay, what are the variables here? Well, you know one's going to be the cost, right? The other is going to be, like, what is it going up by? Well, it's going up by piece of chicken. So my independent variable is going to be the number of pieces of chicken. My dependent variable is going to be the cost, okay? So I'm going to put a C for dependent variable, and I'll just put in brackets cost. My independent variable, I'm just going to say P, and that is for pieces of chicken. That's my independent variable. Okay, as soon as I have all four of these things, I can write my equation. So my dependent variable is C. My rate of change is 1.5 times my independent variable, which is P, and then plus my starting point, which is 26. Okay, and that would be your answer right there. So that is the equation for families buying chicken at Chicken Deluxe. Okay, let's go over the next one. So we'll do two from the sheet. So this is the first one. The second one, okay. The second one is a Chinese food restaurant. Okay, just so you know which one we're on. So it's a Chinese food restaurant. It has a special for groups. It says dinner for two costs, so dinner for two costs $24. Okay, plus $11 for each additional person. Okay, so you should already be thinking about what each of those components of the equation is. Okay, so I will just write above here so I can keep it. The dependent variable equals the rate of change times the independent variable plus the starting point. We'll just keep that there. Okay, so we'll write things down. So we've got the starting point, the rate of change, the independent variable, and the dependent variable. Okay, so I like to write all four of those things out and then we'll fill it in. I actually didn't do that on the last example, but this is generally a good way to do it. So, starting point. Well, if you go in, you're going in for dinner for two, you are going to start at $24. Okay, so your starting point is $24. What is it going up by? Well, it's going up by, or down, but in this case up, it's going up by $11 for each additional person. So that means that my rate of change is 11, right? Add one person, you've added 11 to your base cost. Add two people, you've added 22 to your base cost, okay? So what are my two variables? Well, you know the two variables. One is going to be cost, and the other is additional person. Those are my two variables, okay? Now the cost depends on how many people come in, right? So because of that, the cost is going to be the dependent variable, and the additional person is going to be the independent variable. So down here, I'm going to use, let's say, just A for additional person and C for cost. Now that I have all four components, I can use my general formula to come up with the formula for this example. So I'll have dV is cost, so C, equals the rate of change, that's 11, times the independent variable, which is A, and then plus the starting point. So that's it. If you want, you can drop those brackets and just write 11A, like that. Okay, either one is just fine. Okay, so just a quick review from last week. So today what we're going to get into is writing equations, and instead of them being from word problems like we've done, they're going to be from graphs today. Okay, so let's say you have a graph. We'll just draw a little mini one here. Let's do it in green. Say I have a little one here. As you guys remember, our independent variable goes along here, right? This is our, actually I'll write IV. This is our independent variable. Goes along the x-axis or the horizontal axis. So this is your independent variable. This is your dependent variable. So pretty easy to mix these two up, okay? But one thing I was shown is that you can see this part and this. You can draw a D like that. So remember that this is the dependent variable axis, and you can draw an I like that, remembering that this is the independent axis, okay? So when you're given a graph and you're coming up with the equation, for you to pull out the information for the independent variable and the dependent variable, you're just going to look to what is the variable that's along the independent axis or the x-axis, and what's the variable that's along the y-axis. And it will tell you exactly what should be your independent and your dependent variables, okay? Now, so that's your independent variable and dependent variable. Let's say I had a line like this. You remember this was back when we did rate of change. Okay, so you need to find the rate of change, of course. So the rate of change, when we had to calculate it, we calculated it as the rise over the run. Okay, and that was done with those 5 steps. Remember picking 2 points. So let's say I pick that point and that point, right? And I subtract so I've got x, y for one point, and I've got x, y for another point, okay? Remember that the rise is subtracting the 2 y coordinates, okay? And the run is subtracting the 2 x coordinates, okay? And then divide them to get your rate of change. So we will often have to calculate the rate of change, not just read it off of, as we have been with the word examples, okay? So that's the rate of change for a graph. The starting point is going to be where it crosses the y-axis here, okay? So this one here, that is the starting point. So you would just say, let's say this is going up by 5s, 5, 10, 5, 10, 15. Your starting point here would be 15. Okay, that's for a partial variation example. Let's say you had a line that goes here. For a direct variation, your starting point would be 0 for that example. Okay. Okay, so I think the best thing now is just to get in and do a couple examples so that this will make a little bit more sense. So I'm going to attempt to draw a graph here on the whiteboard. So we've got a distance time graph. So I've got time along my x-axis. That should tell you right away that the time is the independent variable. And I've got distance along the y-axis, which should tell you right away that that's the dependent variable. And this is in seconds. This is going up by 5s. Something like that. And this one's also going up by 5s. Okay, and we've got, and this graph is about students. There's 2 students walking to school. Or sorry, walking to class, because it's actually pretty short distances. Okay, walking to class, and we've got 2, so one goes something like this. It's gonna be a little tricky. Okay, and that one is Brad. And then we've got another line that goes something like that, and that is Claire. Okay, and the question is, I was asking you to come up with an equation for Brad's walk to class and come up with an equation for Claire's walk to class. So you'll do these separately. So let's say I'll do all of Brad in green and all of Claire in red. So Brad, I'm going to write down like I always start with. So I've got my starting point, my rate of change, my independent variable, and my dependent variable. Okay, so you look here and you say, okay, what's Brad's starting point? Well, it's starting, and I know the starting point is where it crosses, crosses the y-axis. Looks a little bit more than half. Half would be 7.5, so I'm going to say his starting point is 8. Okay, 8 meters. Rate of change, I'm going to get back to, because I'm going to have to do calculations for that. But my independent variable is along this axis, so that's time. And my dependent variable is along this axis, so that's distance. So all I need is my rate of change. Okay, so let's pick 2 points. I'm going to pick this one because that's an easy one to do math for. And I'll pick, what's this one? 10, let's go with this one. So this point here would probably be 10 for the x coordinate, and maybe right in the middle, or maybe 13. Let's say 10, 13. Okay, and then this point here is going to be 0 for the x coordinate, and we know it's 8. Okay, so that's my first step, of course, when figuring out the rate of change. So now I need to stack them. So let's do it right here. So 10, 13, and 0, 8. So 13, this is going to be my rise. 13 minus 8, so rate of change, is 13 minus 8, that's 5. And 10 minus 0 is 10. So my rate of change is going to be a half. So I can write 0.5. Okay, so that means that Brad is moving at 0.5 or half a meter a second. Okay, so now you have all the information. We'll just use this and we'll come up with Brad's equation. Okay, so the dependent variable is d, so that's first, equals the rate of change, which is 0.5, times the independent variable, which is t, and then plus the starting point, which is 8. We'll put a box around that. So that's Brad's equation, okay, for his walk. Now to do Claire's, so we'll do Claire's over here. So her starting point, rate of change, independent variable, dependent variable. So her starting point, she's starting right here at the origin, which means her starting point is 0. Okay, her rate of change, I'll get back to, but the independent variable is the same as Brad's. The independent variable is time, and the dependent variable is the distance. Okay, so now to calculate her rate of change, we'll pick our 2 points. I'm going to pick 0, 0 because that is a nice point to do any kind of subtraction from. And then let's say here's a point here, 5, let's say this is 5, 6. Okay, the point 5, 6, so we'll put 5, 6 here. So now I'm going to subtract them. So my rise is the difference, so I'm going to write here, rise is the difference in the y, right? Run is the difference in the x coordinates. So 0 minus 6, that's negative 6, so my rate of change. So my rise is equal to 0 minus 6, which is negative 6, and my run is equal to 0 minus 5, which is negative 5. So my rate of change is going to be equal to my rise divided by run, so negative 6 divided by negative 5, that's going to give me positive 1.2, I believe, 1.2. But let's double check so I don't make a little here. Good. Okay, so my rate of change is 1.2. Okay, so now I have everything, I can put them into my equation. So my d-dependent variable is d equals rate of change, that's 1.2, times my independent variable, which is t, and then plus my starting point, which is 0, so I don't even have to write that down. Okay, and there's the two equations for Claire's walk to class and Brad's walk to class. Okay, so I'm going to do one last example for you. It's from your homework, so the new stuff that's coming out for today. So this will just kind of help you to get started on today's homework. Now, understand that this is a trickier part to the course, okay? So you might have to watch these examples a couple times, okay, before it starts to kind of make sense and you start to recognize the steps and the patterns that you take to get the steps, okay? So this is one from your homework and it's all about melting candles. So on your x-axis you have time in hours, and on your y-axis you have height in centimeters. Okay, so we're burning a candle, we're burning it down, so this is going up by 1, so 0, 1, 2, 3, 4 hours. This is going up by 2s, something like this, 2, 4, over 6. Okay, so the line goes right in the middle here, goes down between 4 and 5. Something like that. Okay, I think I have all the information on there that you need. And the question is, of course, to come up with the equation for the melting candles, okay? So I've got my general equation here. I'm going to write down the components and just fill them in. So I've got my starting point, my rate of change, my independent variable, and my dependent variable. So starting point, this is a partial variation example because it's not starting at 0, 0. So this is supposed to be halfway in the middle. So this is 3. Let's just say that's okay, so for yours, it's 3. So my starting point is 3. My rate of change, we'll have to calculate. My independent variable, here's the independent variable axis, so it's time. So I'm going to put t for time. My dependent variable is height, so I'm going to use h. But now we need to calculate that rate of change. So what two points do we want to use? Points that I see nicely on your example will be a little bit better than on my graph here. This point here is 0 for the x coordinate and 3 for the y coordinate. So that's one point. And another point that looks nice on yours is 3. This should be a little bit lower, but it's the point 3, 1. Okay. So if you're following along on your sheet, this is a little bit more obvious 1, but obviously I've done the best I can for this graph. So there's our 2 points, so I'm going to stack them. So 0, 3, and 3, 1. So I'll subtract these from my rise. Okay, and these two I'll subtract from my run. So my rise is going to be equal to 3 minus 1, which is 2. And my run is going to be equal to 0 minus 3, which is negative 3. So my rate of change is equal to the rise divided by the run. My rise is 2 divided by my run, which is negative 3. Okay? Be careful that you don't leave out signs. Okay, so you get the right sign. So my rate of change is negative 2/3. So you could change that to negative 0.67. It's a repeating decimal. Or you could leave it at negative 2/3. Either of those using in your equation would be fine. I'm going to leave it actually as a fraction. Okay, but like I said, either one is just fine. And you should check and say, okay, my rate of change is negative. Does that make sense? Yes, it does, because you have a downward slope for your line, so you should expect a negative rate of change. Okay, so now I know all four components. I can put them together and write my equation. So my dependent variable is the height. It equals the rate of change, which is negative 2/3, times my independent variable, which is time, and then plus my starting point. Okay, so from your sheet, there's one of your questions done. Okay, so that's it. Let me know if you need any extra help. I can always do one-on-one web sessions if you just need a little bit of help going over any of this. Okay.